Okay, students, today we're going to talk about square root functions here. So first off, function, reviewing definition here. For every x, there's only one y. Another way of saying this, for every input, there's only one output. So you're putting something into equation that's going into the x, and then the output is what comes out, which is the y coordinate. So input versus output, you can also call it the independent versus dependent variable. Which I then bring up over here when I look at function notation. Graphically, it must pass the vertical line test. The vertical line test says if I draw a vertical line anywhere through the graph, it can only touch that graph in one spot. If it touches more than once, it fails the vertical line test, which means that for every x, there's at least two y's, and that breaks the definition of a function. All right, so over here, we have function notation right here. F of x equals the square root of x. F is called the name of the function. It could have been g of x equals the square root of x. It could have been j of x equals the square root of x. That first letter is just the name of the function. It doesn't matter what the variable is. Okay, we just use the letter F because it starts with, it stands for function. You know, these are function notations. So we're just using that to help remind you what it stands, what the idea is, which is function notation. So if it's written in function notation, what that means is it passes, if I was to graph that equation on the right side here, it's going to pass the vertical line test. Okay, if it's not written in function notation, it does not guarantee that it's going to pass the vertical line test, and it may not be a function. But anytime something is written in function notation, it must be a function and thus pass the vertical line test. So that's the value of writing in function notation. So in the past, instead of writing in function notation, f of x, you'd write y. So the f of x is the same thing as the y coordinate of the past. Okay, but like I said, if it's just written in y equals, such as y equals the square root of x, that does not guarantee me it's a function until I actually apply the function definition. But if it's written in function notation, that means it must be a function. Okay. All right, so we're going to talk about square roots. Square root function, what it looks like. Remember from middle school, when you first learned to graph lines, you'd make an XYT chart. Okay, so make an X here, put a Y here. Okay, that Y value is the same as that square root of X. Now, since it's square root of X, I want to pick perfect squares, so I can do it real quick in my head. So the square root of 1 is 1, the square root of 4 is 2, and the square root of 0 is 0. Okay, so those are the three easiest points to then plot. So I go ahead and plot that, 0, 0, 1, 1, and 4, 2. Okay, so square root function looks like that. It goes on forever, arrow. Okay, so this is called a parent function. Parent function means we haven't had any transformations to the original. This is the original, which means it starts at the origin. Okay, you notice there's no plus or minus of any numbers. There's no other number than the x in there, that 1x. There's not a 2x. There's not a 2 out front or a negative out front. This is called the parent function, the basic function. So this is what the general shape is going to always look like. Now we can have shifts from here. So we're going to be talking about these shifts now. Okay, so for example, if I go ahead and do f of x equals negative square root of x, this negative reflects this original over the x-axis. Okay, so what that then is 0, 0 reflects right back on itself. 1, 1 becomes 1, negative 1, and 4, 2 becomes 4, negative 2. Okay, so there is the negative of the square root of x. It just reflects it over the x-axis. Okay, so that's one transformation. That's a reflection over the x-axis. Okay, now I'm going to go ahead and go to the next page and start with the parent function again. And come on. There we go. Okay, So we got 0, 0, 1, 1, 4, 2. That's my parent function every time. Okay, we already did the reflection over the x-axis. Let's say now if I do f of x equals the square root of x and I put a -4 on the outside, this is going to drop the whole function 4 units. 1, 2, 3, 4. And then I still have the 1, 1 and then the 4, 2 right there because the shape doesn't change. It just drops the entire thing. So this goes down 4. The number on the, if it's outside the radical, I follow the same sign. So that's negative, which is down. And this is the y coordinate, dealing with the y shift, up or down. Okay, let's say I do f of x equals the square root of x plus 3. Well, notice that plus 3 is connected to the x. The x is the x-axis, which is left or right. And we're going to do the opposite sign in x direction. Okay, so that was in the y direction up top. This is in the x direction. Y direction. Okay, so what's the opposite of plus 3? Minus 3. So I go left 3. 1, 2, 3. Right there. And then 1, 1 in the 4, 2. 1, 2, 3, 4, 2. So again, the shape does not change. It is just shifted left 3. So how I describe that, it would be left 3. Okay, these are called transformations. We're moving it from the parent function, this red one, and we're shifting it or reflecting it. Okay, so if it's inside the radical, you do the opposite operation. Opposite of plus 3 is minus 3. That means left 3. It's connected to the x coordinate, so left and right is x. If it's on the outside, so it's the -4, it's down 4. If it said plus 4, it'd be up 4. Okay. Now, let's say, I'll go to the next page here, do it again here, and let's say, draw the parent function again, 1, 1, 0, 0, 1, 1, 4, 2. Get used to calling the parent function. Okay, and let's say we have the function negative square root of x plus 1 minus 2. Okay, so now we have 3 things happening here. Remember this negative reflects it over the x-axis. This is how you say, short way of saying reflection over the x-axis, lowercase r, and then a subscript stands for reflection over the x-axis. The x plus 1 makes it go left 1, and the minus 2 makes it go down 2. So we have all 3 of these we have to apply now. Okay. We want to always do reflections first, and then we'll do left or right, up or down, doesn't matter in that order. But so we're going to reflect it over the x-axis. That's the 1, -1, 4, -2 right there. So there's that right there. Okay, then we take that red one and we go left 1, okay, and down 2. 1, 2, right there. Okay, so now we're starting right here instead. In other words, 1 and 1, and then 4 and down 2. 1, 2, 3, 4, down 2. Okay, and so there's my final one. Put this in purple. Okay, there's the actual answer right there. We reflected over the x-axis. We went left 1 and down 2. And there's my graph right there. So this is how you describe it in words. You have to be able to do that and be able to graph it right there. Now these shifts, just so you know, these apply to any function itself from a parent function. It could be a line, it could be a parabola. Okay, we're just dealing with it with square roots, but it doesn't matter what the original is, whatever the fx is. If I put these shifts on these negatives on there, it still does the exact same thing. So if it's a negative out front, it's a reflection over the x-axis. Next to the x, you do the opposite sign. Outside, you do the same sign up or down. Okay. The last type we're going to deal with here is, come on, come on, there we go, is if I put, let's say, 2 square root of x. I'm putting a number out front. Remember, this is my original 1001142. Now, if I put a 2 up front, this goes ahead and makes it steeper. And this is called a dilation of 2. Stretched it by vertical, or also called a vertical stretch of 2. And so I take these y coordinates, these key y coordinates, 0, 0, 1, 1, and 4, 2. I take the y coordinates only and multiply them by 2. So 0, 0 stands still. 0 times 2 is still 2, but 1 times 2 is 2. So instead of 1, 1, it's 1, 2. Instead of 4, 2, 2 times 2 is 4. So it's going to be 4, 4. And there it is right there, and you see how it gets steeper. I multiply all the y coordinates by 2 right there. Okay, and the last one is if I make it, let's say, 1/2 square root of x. If this number out front is between 0 and 1, it's going to be flatter. Okay, so I'm going to take all the y coordinates and multiply by 1/2. So I take those same y's that I just did up top and take the y coordinates and multiply by 1/2. So that still stays 0, 0. This is now 1, 1/2, and this is now 4, 1. Taking 1/2 of the y coordinates. So 0, 0 stays the same, but 1, it becomes 1/2, and at 4, it becomes 1. So notice it got flatter. Okay, so those are the different combinations that we're going to work with in this section here. 12 minutes.